One reason the CTE wanted to sponsor this event was because of the results of the survey that the CTE did just a few weeks ago. Some of you, I'm sure, remember it because you participated in it. In this survey, 343 people responded. 52% said they believe that student evaluations of teaching contribute to grade inflation. 58% said that they have felt pressure to change teaching in ways that would not necessarily improve the teaching. 59% said that they believe that either the student evaluations of teaching should never be used for merit or only be used to identify serious problems. So I was asked to give something of an overview of the research relating to student evaluation of teaching, or SETs, and what we know about them. I'm going to start out very locally. So the first study here comes from LMU, a 2012 study conducted by LMU's Director of Institutional Research, looked at general predictors of SET scores and included 4,918 course sections in doing this. So there are a number of findings there, but some of what they found was that there was indeed a correlation between student interest going into the course and the ratings received from the instructor. There was no significant difference in ratings based on gender, but there were lower ratings that were shown for older faculty and for faculty of color. So the last example, or the last finding there in particular, suggests that maybe there is some sort of bias going on in terms of student evaluation of teaching. We don't really know for certain from that, so we're going to move out now to the literature, the research literature on student evaluations of teaching and how they correlate or don't correlate so much with teaching effectiveness. So in all of these studies, teaching effectiveness is defined really as being learning achievement, usually measured by an exam or sometimes a performance, but some kind of a work product. So the first study I'd like to talk about, and these are all very recent studies, the reference information for the study is there on the screen. Uddle, White, and Juan Gonzalez did this in 2016. It was a very large study, one of the largest studies there has been. And actually, before we get into all of their results, this paper does a nice job, I think, of kind of framing the discussion around student evaluation of teaching, or SETs. And it's good to start there with some of that. So first of all, let me point out, as do the authors, that no one argues that an individual faculty member using the results of their own student evaluation of teachings for their own reflection and development, no one argues that there's anything wrong with that. It's when we get into using SETs for personnel decisions, tenure, merit, and so on, that the discussion gets very lively. Okay, so proponents say, well, students are uniquely positioned to evaluate certain aspects of teaching effectiveness, and of course that assumes that students are able to make observations of the teaching practices and how they contribute to the students' learning. Opponents, on the other hand, say, no, SETs really are just a measure of student satisfaction. Yes? Stand closer. Thank you. Okay, so opponents say SETs really are just a measure of student satisfaction. On the other hand, we've got cognitive psychology that's done a lot of research, and there's good literature out there on what sort of factors or factors play into student learning. And measures of learning, according to that research, are strongly influenced by things like student interest and prior knowledge, prior relevant knowledge from the student. Okay, so when people carry out these studies, especially a multi-section study where you have many sections going on, the gold standard that researchers agree on is that we should have a study where courses have many different sections with the same outline, same assessments. We have students randomly assigned to those sections, each section taught by a different instructor. SETs administered before the final exam and at the same time for all of the different sections, and the student learning assessed using the same final or the same whatever measure it is for measuring. These authors did actually two things. They first of all looked at some prior meta-analysis studies, 3 of them, that are actually pretty highly cited in the literature, and they went back and they reviewed and reanalyzed what is in those studies. So first they found to have some methodological flaws. That's hard for me to say. They found some methodological flaws in the previous studies. They found very strong evidence of small sample study bias, and that can occur, small study bias can occur because when you have a small sample size, correlations need to be higher for statistical significance to show. And of course, authors as well as publishers are more likely to publish something that shows significant results and not so much non-significant results. Also, when they went back and redid the analysis of these previous studies, when they controlled for prior learning, then the set and learning achievement correlations basically went to 0. They really found no correlation between them. The second thing, as I said, they did was that they actually redid a new meta-analysis study. So this one was even larger. It had nearly 100 sectional studies involved in it. They improved the methodology, and they found pretty much the same thing. Again, strong evidence for small study bias. They found that when they controlled for prior learning, that the correlation between the sets and the learning achievement were really not significantly different than 0. Okay, so another set of studies that have come out recently have studied sets and gender, and we'll talk about the first one really, I think, just in terms of the interest of time here. This study had an online course where it was an anthropology, sociology course, which enrolled students from many different majors and different years. Students were randomly assigned to one of 6 different discussion groups. 2 of these discussion groups were taught by a male assistant instructor, 2 by a female assistant instructor. And then each of the assistant instructors taught one section under their own identity and one under their other assistant instructor's identity. So if this had been Vince and I who were the 2 assistant instructors, I would teach one of the sections using my name. I would teach one of the sections using Vince's name. Because this was an online course, the student assistant instructor interaction were really all online. And so almost the only way that students ever had a chance to deduce a gender identity of the instructor was through the name of the instructor. Okay, so the instructors coordinated things. They made sure that they used the same grading rubrics. They completed grading of assignments at the same time, so results came out simultaneously. They had, at the end of the course, students complete a 15-question rating of their instructors, and the male identity received significantly higher scores on professionalism, promptness, fairness, respectfulness, and enthusiasm. And then when we looked at just the male instructor under his own identity versus the evaluations of teaching under the perceived identity, he received significantly lower ratings when he was perceived to be female. Similarly for the female instructor. The authors of this study now argue that this probably, they feel that it probably extends beyond online courses, and they do make a call for replication of the study and further research done on the subject. Okay, so as you have been able to see, a fair amount of the research recently has been kind of negative on sets, that perhaps there's bias in them. There is one study that I didn't present that actually showed a negative correlation between the teaching effectiveness and student evaluations of teaching. So, all right, it is time for me to pass it on to Susie here.
So we're going to move out of the realm of student evaluations and into the other sort of alternative or one of the alternative approaches that many universities use to evaluate teaching effectiveness in professors, and that is peer observation. Many universities use this. I think one of the findings I looked at said that approximately 40% of universities reporting use of this use peer evaluations in summative evaluations of teaching. Let me stop for just a minute and ask, how many of you have received any kind of peer evaluation before? Right, so we're talking to the choir. Good, which is good, because you all know what that involves. So what I'd like to do is just very briefly review the rationale behind the advent of this process in terms of evaluating teaching. And primarily, it has been argued that teaching is a scholarly endeavor, right? And so scholarship should be submitted, even as it's defined in terms of good teaching, to the same kind of review that occurs to written scholarship, which is to say peer review. So hence the advent of peer observation of teaching. Two forms, formative and summative. You all know the formative kind of review is used when an instructor is new or and I'll add this caveat, I am a part-time faculty member at LMU. I've been here, this is starting my 7th year. And so for part-time teachers as well to find out whether or not we're making the grade. And then of course, in terms of a summative review, it sums up the whole performance as opposed to helping an instructor form their craft, right? So those are the two main motivations. The distinction is made further between a holistic review, when all of the materials an instructor uses are reviewed and evaluated, and then, of course, the actual in-class observation that occurs. Now, there are some benefits. I hope some of you who've been reviewed would agree that this can be very advantageous. Those things include that it identifies competencies of the instructor. It recognizes areas of need and development. That's a nice way of saying if you're not doing it very well, you need to do it better so you can keep this job, especially if you're a part-timer, right? It engages colleagues in discussion about teaching strategies, a novel idea, right? Let's talk to one another about what works and what doesn't and how we can support each other. More to be said about that in a minute. It invites self and mutual reflection about best practices within disciplines, which is really a huge benefit as I see it. I've been evaluated in my 35 years of my experience with the Academy 4 times. 3 of those have been voluntarily invited while I've been here at LMU through the Center for Teaching Excellence, and it's always been extremely helpful for me. But there are also challenges that the literature identifies in this process. One of the reasons why it's such a controversial, or can be a controversial aspect in terms of evaluating teaching. There's always that possibility of observer bias. Of course, we hope we're inviting individuals who know our content, understand our learning outcomes, but there can still be biases within the individual evaluator one way or the other. It can also introduce relational stress. That has not been my experience, but I understand, especially if this process is used in summative evaluations, that, you're feeling like someone is evaluating you and your merit or your promotion is going to be somehow affected on this. Obviously, there can be some stress that might be involved. The greatest challenge in what the literature suggests is this notion of introducing best practices in the institution. That would include things such as training individuals to be qualified peer observers for whatever they are observing. So that would suggest they know something about the content, again, the learning outcomes, the teaching setting, is it a lab versus a lecture, that kind of thing. The frequency of observation. So who has the personnel to do this kind of thing on the kind of regular basis that might in fact be extremely helpful, especially in terms of the formative process. Whether it should be used for formative versus summative evaluation, and then, of course, that big old booger of institutional cost. What will it cost to train individuals to be raters? How do we do that? What does it cost in terms of time? All of those kinds of things. So clearly there are some challenges to this process. One of the things that occurred to me when Suzanne and Vince and I were reflecting on this yesterday is that a huge benefit, especially speaking from a part-timer's point of view, that can occur in this process of peer observation is that you can learn best practices from colleagues, right? If you're being mentored, you want someone to come along and help you step up your game or introduce different ideas. You can trade those things back and forth. But I think one of the more important things in terms of this university is that it introduces an opportunity to engage in very civil, supportive, encouraging dialogue between peers in an age when we clearly have many more models of uncivil discourse. And I think that in itself can be a real benefit to this kind of process in a university. And that's all I'm going to say right now.
You've heard about student evaluations and peer review, which are the most common forms of evaluation at LMU and elsewhere. So what I'm going to talk about are some other things that are less common and offer the pros and cons of some of those. So four of those, measuring directly student learning outcomes is one that would seem to be sort of obvious that one might try to use. A second would be using research-based teaching practices. A third would be dissemination of materials and methods to other instructors as evidence of one's own teaching effectiveness. And finally, and this is one that's used at LMU as well, is self-assessment. So let's look at each of those in order. So measuring student learning outcomes. Now, in principle, this is a great way to measure effectiveness. What is more important if we can have a direct measure of how much our students are learning? But in practice, there's some really serious problems with this. First of all, you have to account for student differences for the student population. So your students do really well maybe on a standardized exam, but maybe you got great students that semester, you know, or maybe they did poorly, but you may have gotten very poor students. So the student populations matter very much. And if any attempt to measure your effectiveness has to take that into account. Now, it's possible to do that in some fields in some ways, but even if that is done, there's still another, and I think a more important problem with that. And we saw that when No Child Left Behind was instituted, and many elementary grade school teachers were trying to bring up the scores on standardized exams, and what we found is there was cheating. One didn't want to believe that people would do that, but if it's high stakes enough, there will be cheating, and I have no doubt. If we made this a very high stakes measure of you know, your teaching effectiveness, there would be some. And so there was a paper by Nichols and Berliner claiming that this is inevitable, the inevitable corruption of indicators through high stakes testing. And so I think for that reason, really not such a good idea. Okay, I want to look at something else that I think is more promising, and that is use of research-based teaching practices. Now, some of those practices are broadly applicable, others are very domain-specific, and a very specific version of that was developed by Carl Wyman. So how many of you were here or saw the recording of Carl's talk in which he presented that? Okay, so a few of you at least have seen that. So he went a step further and said, look, let's look at what research tells us are the most important teaching practices, and when those practices are used, show that learning is greatest. And then let's simply ask people what they do. Now, this is a verifiable thing. You can't, there are very specific things in the instrument that he developed. You either do those things or you don't. And if you do those, it should lead to greater learning. So it sounds like at least a possible way to go. Let me mention, though, because the criticism of this is, well, that's all well and good for physics, or maybe physics, engineering, and other technical fields, but how does it apply to other things? And I think there is the potential for applying this to other things. If we look in particular at some of the books that have been written, especially in the last several years, about research-based teaching methods. So there really is research. It's not just all about, let's do what our favorite teacher did years ago. That's how I started out teaching, and I found after a long time of teaching that really wasn't very effective, even though I thought he was an incredible teacher. And so gradually over the years I began to adopt that. So here's a book, and I want to mention some of these books because I would encourage all of you to take a look at them. And we have copies of those available through the CTE, so they're available for anyone to check out, read, see what's applicable to you. One of those is the book by Dan Schwartz. Carl Wyman quotes this as being an essential book for every teacher. It's applicable to all disciplines, and it covers a variety of things, including motivation, study skills, problem solving, and so forth. So it has some very specific ideas. That was just published a year ago. There's a couple of others that are more recent. How People Learn from the National Research Council in 2000. This is a great book. It's not so much directed just at college. It's broadly applicable, but very interesting examples there. But it does have a diversity of examples from different disciplines as well. So it includes math and physics, but also history, literature, writing, many different fields. And finally, again, a fairly recent book, 2010, How Learning Works, by Susan Ambrose and others from the Carnegie Institute. And this is intended, again, for all college classes, so college instruction. It's based on research in education, research in cognitive and social psychology. So lots of research, and it provides very general principles, but not only the principles, but very specific advice. So I encourage you to look at all of these. And I would mention just a couple of others. So we've got all of these available at the CTE, so feel free to check these out with Katie at any time. There's others that are more specific to disciplines, so I'll just hold up a few of these. If you happen to be in a science, engineering, or mathematics field, Carl wrote one, Improving University Science, Peer Instruction is another. So there's a variety of these as well. Okay, so I do want to mention Carl Wyman's experiment. So some of you have seen this already, so this is a little bit of a repeat, but I think it bears repeating. It's a very impressive result that he found in 2011, demonstrating how teaching practices can dramatically change learning outcomes. So here I'm just using Carl's slides again. So he set this up in a very interesting way. He had two sections of a physics course. These are large sections, something we don't have anything like this at LMU. So there's a large amount of data, 270 students in each section. And he had two instructors. One was a very accomplished, well-evaluated, popular instructor, had been teaching the course for years, a very accomplished instructor, and the other was a new PhD, but one who had been trained in these new research-based teaching methods. And so what do you think happened? Well, if you've seen this, you already know the answer. Now, they sat down and worked out the learning objectives. They had common content. And this was just a one-week experiment. It'd be difficult to do this over a longer period of time. But they did this for 1 week, had common content and learning objectives, and they wrote the exam together, a series of questions at the end of the week, conceptual as well as mathematical problems, and here was the result. I think this is a mind-blowing result. The new PhD Look at the distribution there. The average is 74%. But look at how many were close to 100%. It was 12 questions. And at the other end, very few reached even 50%. The average was 41%. So it's just really a clear-cut case of the demonstrating, I think, maybe more clearly. Now, there's a lot of data in physics education that shows similar stuff, but this, I think, is one of the most remarkable. And the teaching practices inventory, if you want to take a look at that, there's a reference to it in Carl's talk and here as well. So let me mention quickly just a couple of other methods. One is dissemination of novel methods and materials. This seems to be a fairly obvious thing. It was recommended by the Carnegie Foundation in 1999. There is a criticism of this, however, that is that, well, not everybody can do this. Not everybody can do educational research. And my answer to that is, yes, you can. You actually can, and LMU's CTE provides the resources for you to do that. So if you're interested in doing this, you can do the research. That's how I started many years ago, with a small grant from the CTE, and since then I've done a lot of published research on this, supported by a teaching grant. There's also travel grants. There's materials you can present at the CTE. So the answer is yes, all of you. If you're teaching and you're interested in developing your teaching, why not do some research in it? Okay, and let me finish up with self-assessment. This is listed last, but by no means the least important. In fact, in some ways, maybe this is the most important. It's obvious we're all a little bit biased when we're evaluating ourselves, but we also are the ones that know ourselves the best and are able to evaluate ourselves. So I think that reasonably this should be part of any teaching evaluation, and it's really an opportunity to bring in any of these other elements as well. So you can report in your teaching, in your faculty service report, on anything you want, and hopefully if it's something reasonable, that will be considered. And the committee that last looked at this in 2013, the Committee on Comprehensive Evaluation, advocated for the use of teaching narratives, and so that's available on the CTE site. You can look at that, and that provides some guidance for elaborating in your faculty service report on philosophy and then on the methods that you're using. And I think that concludes our formal presentations.
The outcome of that, better results just across the board, was that attributed to the fact that they were more consciously engaging with the course, conferring on?
Well, it's the specific methods that were used, and I, it's difficult to go into those right now, but we could certainly talk about what those are. The sort of the buzzword in physics education is interactive engagement. And so physics actually used to be the worst of all the disciplines in this regard. When I started teaching many years ago, I modeled my teaching after my advisor, and it was a straight lecture method, and he was a brilliant lecturer. So I did this for years until I discovered, using analysis of student data, that my students weren't really learning. And that was discovered across the board. If you use, in teaching physics, simply lecturing, students will not learn anywhere near as much. And there's a vast amount of research on that now. And so the buzzword is interactive engagement. There's a variety of ways of doing that. One of them is using clickers, and we'll probably have some clicker events at the CTE coming up. How many of you have used clickers? Oh, just a few of you. How many of you have heard of the use of clickers? So let me just tell you what a clicker is. So a clicker is not an end in itself, okay? It's a very convenient tool for getting students to engage with each other in a problem. So the way I use it, for example, I will lecture for a few minutes, because I still believe in some lecturing, and then at the end of that, I'll try to give a question that is challenging very challenging. And I'll ask the students to respond with a clicker, and what I see then displayed is a histogram of the responses. Now, if the responses are all correct, which occasionally happens, that's great. You move on, you know that they got it. But more commonly, there's a distribution, and sometimes none of them get it right. But whatever the outcome, if it's not practically all correct, you then simply stop and say, okay, now engage with your partner. So I have assigned partners in the class, and these are people they talk to regularly. They're seated next to them, and they have to defend their answer to their partner. They have to argue it out. So even if it's wrong, they're arguing, they're truly engaging. They're not just, now what would not work is simply me, okay, well, you guys all got it wrong, here's the right answer. So that would be using a clicker the wrong way. It's not about the clicker in itself, it's the use of the clicker to engage discussion. And so then after that, engage discussion for several minutes. When things start quieting down, they've made their argument, then we vote again. And that second vote, sometimes things are all cleared up. Sometimes they're just as bad. We might go through another round, or maybe I'll give them a hint. But in this way, there is truly engagement. Now, that's just one method. So I don't claim that that's the only method. There's many ways of engaging, but that's an example.